Hello, I'm Weiman Kwan, creator of the WMK Math channel. In this video, I am going to talk about solving equations. In this second part, I am going to focus on solving multi-step equations. In this video, there will be two key ideas that will be covered. First, there is a brief explanation of the key ideas of solving any equation. This will be a review from the previous videos, but these are important ideas in solving any equations, especially complex ones. Second, I am going to show how to solve different types of complex equations. There are going to be different examples of different situations that you may encounter, and the strategies to solve these equations. Let's look at the key ideas of solving any equation. When one is manipulating equations, the equations must remain balanced. To keep equations balanced, whatever we do to one side, we do to the other side. Meaning, if we add, subtract, multiply, or divide to the entire left side, then we have to do the same thing to the entire right side. When we are talking about solving the equation, the goal is to manipulate the equation so that the last line is x equals something. This process is known as isolating x from all the other math operations surrounding the variable. The best way to deal with these math operators around the variables is to use opposite math operators to get rid of them. For example, if there is an addition term, then we use subtraction to get rid of it. Even though the goal of solving equations is to isolate x, it doesn't mean there is only one path to getting to the correct answer. In complex equations, there are often multiple solutions in solving the equation. As long as all the proper math rules are followed, that solution is considered good and correct. Here is one last key idea. In simple equations, one can just simply manipulate the equation and get to the final answer. However, complex equations will require the use of algebra rules and simplifying the equations first before equation manipulation. In even more complex cases, one might need to just simplify first, then manipulate the equation, simplify again, and then manipulate again. So, it's a cycle of manipulation and simplification. This cycle is repeated until the user solves the equation. In this first example, we have 2x plus 3x equals 7 plus 8. What do we do here? The first thing we should look at is to locate where the variable is. In this equation, both variable terms is on the left side of the equation, and the numbers are on the right side of the equation. Since the left side has like terms, and the right side also has like terms, we can simplify both sides. On the left side, the result is 5x, and on the right side, the result is 15. Hence, the equation so far is 5x equals 15. From here, we simply divide both sides by 5, and the final answer is x equals 3. In this second example, we have 6x plus 7 equals the 4x plus 23. The first thing we should do is to locate where our variables are. In this example, there is a variable term on the left side and also on the right side. We also see that there is a number term on both the left and the right side of the equation. Whenever you see this case, the strategy is to move all the variables to one side of the equation and all the number term to the other side of the equation. In this case, I want all my variables on the left side and all the numbers on the right side. My first move is to move all the variables to the left side. To do that, we need to get rid of the variable term on the right side. The variable term is the 4x on the right side, so the manipulation we will do is to subtract 4x from both sides of the equation. As a result, the left side simplifies to 2x plus 7, and on the right side it becomes 23. The next move is to move all the numbers to the right side. To do that, we need to get rid of the number term on the left side of the equation. Since this term is a 7, we need to subtract 7 on both sides of the equation. The result is that we have 2x on the left side and 16 on the right side. From here, we divide both sides by 2, and the final result is x equals 8. In this third example, we begin with 2 times 3x minus 4 equals 16. I'm going to show 2 strategies in dealing with this particular case. The first question that needs to be asked is, where is the variable located? In this particular case, the variable term is on the left side, but it is inside a bracket. When there is a variable term inside the bracket, we have to free the variable term before doing anything else. To get rid of this bracket, on the left side, I'm going to use the strategy of expanding this bracket. The 2 outside of the bracket is multiplying everything inside the bracket. So to expand the bracket, I multiply 2 to basically everything inside the bracket. And the result is that we have 6x minus 8. The right side remains unchanged at 16. Now this should be a familiar case to deal with from here on out, as the equation is currently 6x minus 8 equals 16. So our next move is to remove the minus 8 term on the left side by adding 8 on both sides of the equation. This results in 6x equals 24. Finally, to solve the equation, we divide both sides by 6, and the resulting answer is x equals 4. Let's see a second strategy in dealing with the bracket term. One can see that only the left side has a bracket with things inside, and there is only one bracket, which is multiplied by that 2. On the right side, there is simply just a number. Hence, we can get rid of the 2 another way. We can divide the entire left side by 2. To ensure balance, we also have to divide the entire right side by 2. The resulting equation so far is on the left side we have 3x minus 4, and on the right side we have 8. Now we have a familiar case to deal with, as the equation stands at 3x minus 4 equals 8. The next move is to get rid of the minus 4 term by adding 4 on both sides of the equation. This results in the equation being 3x equals 12. Finally, to solve the equation, we divide both sides by 3, and the result is x equals 4, which is exactly the same as the previous method. Before moving on, there are 2 things I'd like to talk about. First, notice how the 2 strategies are different, and not in just the way of thinking, but the numbers that can be seen while showing work. Having different numbers doesn't mean your work is incorrect, but as long as all the proper math rules are followed, the final answer should be the same with both methods. Second, this second strategy is just not as versatile as the first strategy. In order to do the first step, one must ensure that there is only one bracket term on one of the sides. If there are 2 or more bracket terms, then you cannot use this strategy. This is especially true when there is a bracket on the left side and a bracket on the right side. In the first strategy, you can just simply expand regardless of how many number of brackets there are. Hence, this strategy typically works in more cases. That's why I prefer the first strategy here. However, it doesn't mean that strategy number 2 is not a good strategy. Let's take a look at the fourth example here, which we have 3x minus 5 divides 5 equals 2. The first thing is to identify where is the variable term is located. In this case, it is on the left side, but it appears to be in between quite a lot of things. The most confusing part about this question is the left side of this equation. So how do we read this? This is another way of writing division. In other words, everything on the top of this giant line is divided by everything on the bottom of this giant line. So if we were to rewrite this using brackets, what we do is we put everything on the top first in brackets, then write a divide, and then we put everything else on the bottom in brackets as well. In our example, the 3x minus 5 is on top, so that's the first thing we write. After that, we put those terms in brackets and then put a divide sign. Then we put the 5 from the bottom of the line into our next line, and we should put brackets in between the 5. But since it's only one term, we can just ignore it. So essentially, what we have here is 3x minus 5 in brackets divides 5, and it equals to 2. Now, what is the next move we want to make here? In the previous example, there are two strategies that was used. We can eliminate the term by using equation methods, or we can use the distributive property to simplify the brackets. What's the best strategy here? When you see a division term, it's probably not a good idea to simplify, because dividing by each term, you might get some very nasty numbers to work with. For example, if you divide the 3x by 5, the result is 0.6x, which is not that easy to deal with. Therefore, the strategy I'm going to show you is to use equation manipulation here. Since the bracket is divided by 5, we multiply by 5 on both sides of the equation to get rid of this divide 5 term on the left side. As a result, the left side has only 3x minus 5 left, and on the right side, we have 10 remaining. From here, this should be a familiar case to deal with. We first eliminate the negative 5 term on the left side by adding 5 on both sides of the equation. This gives 3x equals 15. Finally, from here, we divide both sides by 3, and the result is x equals 3. Let's take a look at the fifth example here, in which we have 2x minus 3 divides 3 equals to 4x minus 4 divides 5. First, where are the variable terms located? We can observe that the variable terms is located on both sides of the equation. One can also note that these variables are surrounded by various other operations, especially the divide term on both sides. So what do we do here? If we take a look at both sides carefully, the entire side is a top divide by bottom situation. Also, there are no additional terms outside of this dividing situation. When you have a top divide by bottom situation on both sides of the equation, you can use cross multiply to deal with this situation. In other words, the top of the left side multiplies the bottom of the right side is equal to the bottom of the left side multiplies the top of the right side. So in this case, if we use cross multiply, the next step will look like 2x minus 3 in brackets multiplies by 5 is equal to 3x minus 4 in brackets multiplied by 3. Using algebra to simplify both sides, the left side becomes 10x minus 15, and on the right side, it becomes 9x minus 12. Now we see a familiar case here, as seen in the second example in this video. So how do we deal with this case? The strategy here is to move the variables to the left side and the numbers to the right side. Let's start with the variables. We see on the right side, there is a 9x term. So to remove this term, we subtract 9x on both sides of the equation. The result is we have x minus 15 on the left side and negative 12 on the right side. To finish this equation off, we add 15 on both sides of the equation, and the final result is x equals 3. This concludes the video about solving complex equations. There are many different types of equations that exist, and this video showed some of the common situations you will encounter. I hope this video provides insight on the strategies of dealing with these equations and laid the foundation on the thinking process of solving other types of equations. Feel free to give your suggestions or comments by writing below. You can also email me at weimanquant87@gmail.com. Thanks for watching, and I hope to see you again next time.